and help fit well with LLMs development and help explaining the direction in which this specific technology goes. So, first of all, if you want to, during the lunch, I've just been told by Eve that QR codes are not secure. So, but I already had the slide. So, however, a couple of readings to see what we do in this field. One is actually a blog post in my institute, which is GREDEG, so not so far from here. Pullulating of people studying AI from a socio-economic perspective. The other is a scientific paper. They do not talk necessarily about or specifically about LLMs, but they give you a perspective on what we look at when we study them. So apologies for the QR code again. So as you know, large language models, as we said, are the undisputed actor, the undisputed star in the AI field nowadays. AI is not only LLMs, AI will not be only LLMs, but now everybody talks about LLMs. So this is because on the one hand, there is clearly a lot of potential value to be created and extracted through the usage of large language models. The other reason is that, as for AI in general, there is a lot of hype. I don't know if you ever encountered this new acronym that has been introduced. So now we are in the FICTA moment. FICTA is failed in crypto trying AI. So a lot of people have been pouring money in cryptocurrencies and crypto system, and then they have been, not doing that well, so a lot of resources are now rewired toward artificial intelligence, which means a bounty of resources, what means also trajectories that are maybe not so valuable in the medium to long term. And my take here is that instead of just tracking every single day the new model that comes out, the new application or use cases, can we extract some general patterns that we can use to try to map what is going to happen? So to do that, of course, as an economist, I would suggest, okay, maybe a different angle from computer science, software engineering would help. So what about economics? And indeed, that's what I'm trying to do. So the first thing to discuss is, once again, after the talk of Frederic, it doesn't make so much sense, but what are large language models? Here I would recommend a nice paper that is now on Archive, but it's a very short one from Sasha Luccioni and Anna Rogers that discusses, try to define what are the boundaries of large language models. So in a very, very, very nutshell, a language model is a probability distribution over language. So we discussed it before. Language models are big autocomplete, if you want. So passing the data, text data through the algorithm, then you might predict the new tokens given prompts, inputs, etc. What counts as a large language model? Then the discussion is, does it depend on the number of parameters? Does it depend on the type of functions done? Is having a transformer architecture a necessary condition for being labeled a large language model? What is the difference between large language model and foundation models? That's also yet not completely clear because different communities have been introducing these definitional concepts. In the paper by Luccioni and Rogers, they come up with 3 criteria saying that LLMs, they do model text and can be used to generate text. That's not only, but mostly. They receive large-scale pre-training. So what is large? That doesn't have to necessarily be parameters. So you might have tiny ML models, for example, but they are trained on large swaths of data. And then they suggest at least 1 billion tokens. And they are used to make inference based on some form of what they label transfer learning, but let's say prompting or fine-tuning and so on and so forth. So under this type of criteria, you will have that all the things that descend from BERT, as it was introduced today, they are large language models. GPT-4 is in the category, so it's a large language model. Word2Vec may be out of large language model as it doesn't model the whole embedding story. So this is a sort of first boundaries of the story, what I'm interested in is two related things. One, LLMs as an engine, like a prediction engine if you want, so the technology itself, and the other are LLMs as products, so when they are packaged as solution that can be sold on the market, adopted by users in different forms. So despite its importance, I'm not going to discuss today about other things like the robustness of LLMs, it was mentioned before, so the biases of LLM, the brittleness of LLMs, all the issues related to liability of using these systems, about the intellectual property issues related. I will mention briefly about data, but Frederic already mentioned that what we know about the GPT series and the type of data sets that are included in the training, some of them might be questionable from an intellectual property protection viewpoint. But instead, I'm going to focus on the product. And two broad issues that I would like to look at or start to think about are indeed, one has to do with the topic of the conference of today, which are the expected transformation of the society when LLMs enter the game. And the question is that, are LLM going to be part of or engine of a transformation of the society based on what Suleiman, who is the founder of now I do not remember the name, but one of the emerging AI companies, the interactive AI phase. So we had the deep learning phase, we had the generative AI phase. I mean, you can discuss whether this distinction makes sense, but what it suggests is that we are entering the interactive AI phase in which we have LLMs that develop several functions to allow users to interact between them and with other programs. So why is that important? Because if we can answer this question, we can understand which are possible future use cases, which are the possible emerging user applications, so which are the development trends for this technology, and also because from a very, I would say, managerial viewpoint, you can understand where as managers like to say, where the locus, where the place of value creation and value extraction is, so where you can make money out of LLMs. Then the other question is that, can you really make money out of LLMs? But we're going to discuss that later. So this is the first point, the first hypothesis, the first topic around which to arrange the discussion. Are you still with me? Good, thank you. And the second is whether so at least when I started to study AI a few years ago, before COVID, it was not even sure that we could talk about an AI industry. Defining what is an industry is always ambiguous, because what are the boundaries of the industry? Are there products? Are the main line of business of companies? Is it standard classifications? But now it's clear that there is, if you want, a very complex technical stack that develops, that then maps into ecosystem of actors that specialize and do different things. Some do more things, some do less things. So there is somehow an AI industry. And then the question is whether LLMs represent, from a product viewpoint, what scholars of economics and industry dynamics would call a dominant design for the industry. So many industries, they tend to evolve from their birth to maturity, and they tend to see the emergence of what are called dominant design. Example, all your mobile phones, they look like a brick with one screen that is touch screen. But that was not the case. When I was younger and beautiful, I had a BlackBerry, so I had a keyword-based mobile phone, which was this bridge between the phone and the smartphone. Okay, so that was another type of design. Actually, RIMs or BlackBerry, they tried to survive by introducing the BlackBerry Passport, which was a sort of a passport-sized telephone, which had a different measurement than now dominant smartphone, and it did not succeed. Exactly because of the theory of the dominant design. When an industry evolved, the main product produced tend to assume a dominant design, so it's a certain architecture from which is very hard to escape. Why it is very hard to escape? Because consumer kind of converge into that. So if you do something different, you likely fail. Why is that important? Because if we detect that LLMs are somehow the dominant design of the way in which AI products are constructed, this is equivalent to barriers to entry. So if you don't do that, you likely stay out the market, okay? Or if you really want to barge into the market, you need to do additional effort. But if you want to do additional effort, you need to have the finances, the resources, the ideas, and you might not have them if you are a startup, for example. Or you might have them, but you might not survive. So once again, if we understand that this is a part of the AI industry that is stabilizing, then we can also try to predict where the investments go. Should it go more on compute then? Should it go more on devices then? Should it go somewhere else rather than on algorithms? Or should it continue to go to models? Okay, so these are two broad things one can start to think about. And how can we not address this question, but how can we build some tools that allow us to elaborate on that? Well, some LLM economics. First, I don't know, you might have, I mean, you are software experts and computer science experts, but one key concept here is the one of information goods. So standard goods are, I mean, physical goods, like this stuff here, okay, or this computer or this table. But in the digital economy, many goods are information goods. Any book, a file, I don't know, anything that can be digitized and transferred through computer-mediated transactions, if you want. And the whole digital economy is not only based on information goods, but is characterized by the pervasiveness of information goods. And information goods, they have a specific economic characteristics. They have three at least that now I'm going to list. But the key one is that while most physical goods are characterized by what are called decreasing returns to scale, so if the more you want to expand production, the more your additional cost for each additional unit will increase, okay? So you have physical limits of expanding physical production. Information goods, they usually are produced by high fixed costs, and then they have very low marginal reproduction cost. So think about any book. The high fixed cost is that you need to pay the author the rights to write the book, okay? But then when you have the file, you just, I mean, make trillions of copies, okay? What does, so these are the increasing returns to scale. Once you pass over this step of producing an information good, then you can flood the market with it. Implication of that is that if you are the first to do it, so the more you scale up the production of the information goods, you very much likely become the monopolist. Because the follower, they cannot, they started with less scale, so they cannot catch up with you. So a lot of digital markets, they naturally tend to tipping, meaning they tend to become monopolies. So controlled by one firm or few firms, okay? Furthermore, information, all goods, but information goods even more, they're characterized by economies of scope. Think about, indeed, the LLMs. So you need, there are what are called cross-domain data economies of scope or cross-domain data feedback loops. So you collect data, you use the data to refine your product. This product is put on the market. By putting on the market, you collect more data. Through the data, you will either refine your product or expand the scope of your products. So if you are, once again, the first entrant in the market, you will gain advantage over the others, becoming dominant. And some information goods, they are characterized by what are technically called consumption externality or network effects. Network effects are the feature of information goods that somehow suggest that the value for a user of an information goods is a function of the user base. Translated, if nobody's in WhatsApp, you have no incentive to install WhatsApp, okay? If nobody, once again, it's not only for information goods, if nobody uses telephones, like landline telephones, you have no incentive to use a landline phone, okay? But a lot of goods are, their utility depend on the number of users. This will return in a second as a point. Now, you do not care how many users use ChatGPT, okay? So you do not have direct network effects. Actually, you might have direct negative network effect if there is saturation point. So if you cannot use ChatGPT, you will have a negative impact on your utility. But you might have cross-group network effects. So think about not ChatGPT, but think about any website or even a newspaper. You have different types of users. You have the advertisers and the users. So the advertisers want that more users are on the platform or on the service, because the more there are, the more eyeballs to look at their advertisement. The users, they want less advertisement. Okay? So they have negative network effects. If you are a producer of an information good that connects different communities of users, then your point would be exactly to succeed to design incentives, for example, the price, to make some part of the users that have negative network effect to jump on board anyway, so that the other group that will stay on board because the first group enters. So this applies to many things. Think about the newspaper. So you have a magazine, you have a lot of advertisement, you have a lot of readers. So the more readers, the more advertisers. But the more advertisers, the less readers. So the newspaper, they will make either the magazine very cheap so that you buy it anyway, or it will make at a certain price but will slot, so reduce the number of advertisements so that people do not get bored. The same holds for any, as we're going to see, platform or what is labeled two-sided market. So if you go on Amazon, you have sellers and buyers. If you go on any other, if you go on Airbnb, if you go on Deliveroo, whatever. So you have always two sides or multiple sides which cross incentives to stay on the platform. Information goods, they tend to have this feature. Now, LLMs not necessarily have it, but they tend to be this type of products with multiple type of users that have different utilities based on how the different users use the product. So how is that relevant for LLMs? So LLMs, they are not just information goods, but they share some feature of information goods. So in the end, the software part is an information good. So it's highly replicable. Okay? So if you introduce a new model that is very successful, then you can easily gain market share. However, LLMs, they are also partially physical goods, because the AI systems are systems. So you need the compute. Okay? And the compute not necessarily has economies of scale. So this is something that we are still looking at. So you need to double, triple, quadruple the number of servers or GPUs or NVIDIA A100, A200 if you want to double, triple, or quadruple the number of users. So still, partially, it's a sort of a composite good, the LLM. Partially, it has marginal cost, so the more you have users, the more it will cost you as a producer, but it also has a strong component of replicability. Hence, some of the actors might become landlocked dominant. Yeah, so that's the first feature of the first thing that we can take from economics of digital markets for LLMs. The second is the concept of price discrimination. Do you know what price discrimination is? So price discrimination, the word discrimination is never nice, but in the literature it has been used like that. So just, it's the idea that a company can offer different products, can offer a product to different users at different prices. Okay? Now, there are different types of price discrimination. The paradise of economists is, of certain type of economists, is first-degree price discrimination, which literally equals to personalized pricing. So what companies dream of is to be able to assign to each of you an estimation of what is called your willingness to pay, so how much you will be likely to spend on a good, and to offer you that good at that price. Because what happens is that if Lucille wants to pay 100 and I want to pay 50, if they charge 100, I will not buy it. If they charge 50, we will both buy it, but they lose 50 euros on Lucille's willingness to pay. So in this case, they would be indifferent. But imagine that each of you have a different willingness to pay. So what is happening in the digital world is indeed that companies try to, let's say, converge toward first-degree price discrimination. What is happening? They collect information on you, and they would have liked to give you personalized pricing. What has happened in the real world is that you don't find personalized pricing because people get pissed. So if I sit next to my wife and we check a flight of EasyJet and we get to different prices based on our purchase history, we're like, what the heck? Okay. What they give to you, though, is personalized advertisement, which is an indirect way to introduce personalization into your purchase history. Okay, but that's one type of price discrimination, which digital markets have anyway made easier, okay, because you can track consumers in their choices and better estimate person by person willingness to pay. You also have what is called third-degree price discrimination or group price discrimination, so why elderly people and students, they pay less the bus or the train because their group has less willingness to pay, so they will be charged less or more, okay? But what is interesting for us is what is called second-degree price discrimination, because second-degree price discrimination is what is called versioning, or creating different menus or packages of a product to appeal to different structure of preferences of the consumers, okay? And this is not a novelty of LLMs. This is all the software is like that. So you have the premium version, the simplified version, etc. But you saw in the talk before that what companies start to do is to create, indeed, to try to attempt versioning, combining different forms of the models with additional packages of services to provide tailored pricing to different customers, okay? So, and this is interesting, why, which is the point, what is the relevance for LLMs? Because we see this now, okay? So if you look at the models, so Llama 2, you have the Llama 7 billion parameters, the 13 billion, the 70 billion parameters. Of course, I mean, these are different structure of the product offering. So these are different versioning that are constructed to appeal different type of users. And Mixtral, you have the 7B, the 8 times 7B. So, and this somehow is something that we need to start to map because it tells whether the LLM-driven market is sustainable or not in the medium to long period, okay? So can the market sustain all these different product offering or not? And so once again, this is not something new for LLMs. This is something that we have seen in all the goods. We see them often, and actually digital goods even more. So one type of versioning is bundling. Bundling is that you put together actually different goods at one price, so you cannot sell them. You can also sell them separately, but you cannot sell them separately. And you know, in the digital economy, this is a very common use strategy. So if you want, Netflix is a mega bundle. So it's instead of buying every single movie, you purchase one abo. Why so? Because economically speaking, if you let's say want to purchase movie by movie, for each movie you will have incentive to deviate and to pirate it or to download it illegally. But if you're offered a mega bundle with different tastes and different options, then your cost to deviate for every single movie is higher than the cost of paying the subscription to Netflix, hence you will go for the bundle. So since the introduction of mega bundles, actually piracy has decreased a lot. So I was using Napster, even though I shouldn't say it on YouTube, but now, I mean, some time has passed, or similar services, and now you're like, okay, you know, 10 euros, let's get it. Then, I mean, maybe the quality we can discuss, but still. So versioning is important for LLMs because it is the way in which the LLM products are structured and then put into the market, okay? A third very important concept that you will know better than me is the concept of platform, okay? So platform is a very generic concept. So usually you can define it as a platform is an architecture of something. Or better, is a set of stable components that support variety and evolvability in a system by constraining the linkages among other components. Which means that many things can be structured as platforms when you have a core and some complements. So Amazon or Deliveroo is a platform because it's a website, and the component are the users and the drivers. Okay, this is a platform because it has a motherboard with a CPU and some other components, and then it has a screen, a keyboard, a mouse, which are complements. A shopping mall is a platform because it has an architectural structure, and the shops are actually exchangeable. You can close them and open them, and they are the complements. So many things in the contemporary market are platforms because this is a structure that helps reduction of uncertainty and production of variety. Okay? You can substitute the complements and renew the core. And indeed, this is a concept that has been developed in many different fields, from product platforms. So, for example, I've been studying semiconductor industry, and then you see that system-on-a chips, they tend to be platform chips. When you if you take the M1 or M2 chip of Apple, you will have a CPU, a GPU, a TPU, some memories, and so on and so forth. So these are the complement of a core product. But you have, as we learn to call them, you have platform marketplaces. Amazon, Google for advertisement, yes, or for search, any other, so Airbnb, once again, they are all platform, but the concept is the same. Why is this important for LLMs? Because at least what seems to me is that we see potentially the attempt of LLMs platformization. So you might have heard a few days ago the launch of the OpenAI GPT store. And what is the GPT store? Is a set of functional callings, so plugins that ChatGPT can call or you can add to your account that allow to expand the capabilities of ChatGPT. Then if you look what these apps there are, they tell a lot about the problems of AI. Is the digital girlfriend, which tells a lot about all the nerds that are developing AI, that maybe they should do some lesson in inclusiveness and respect. You have a lot of literature reviews, which seems like academics use a lot. So productivity tools. So it's not exploding at the moment, but still, we are at the beginning of that. So why introduce that? Because the concept of platform, as it applies to marketplaces, as it applies to technologies, it might apply also to LLMs. But as you're going to see, this is only one of the possible futures that I've been thinking about. A more interesting concept here that I mentioned before is the one of two-sided or multi-sided platforms, which are the platforms that connect different type of users. So Google is not only a search engine, is a multi-sided platform because on the one hand you have people that search for information, and on the other you have advertisers that advertise on Google. To return to the point before, the economist point, how much do you spend to search on Google? Nothing. Why do you spend nothing to search on Google? Because of the network effects. Google charges you nothing, even though they have, server farms, electricity, etc., because they want to have the largest possible user side, because the more users, well, the more advertisers. Okay, so what many platforms that are two-sided platforms, so that connects to type of users have been doing in the digital economy, they've been giving up services for free. Price is zero. That is a huge problem when we talk about another topic we're not talking about today, but that was mentioned a bit about concentration of power, because if you are an antitrust institute or a competition policy organization and you want to limit market power, you usually look at price levels. So once again, if the price levels are high or more, the marginal cost means that there might be some market concentration, some monopolization. But in the digital market, exactly because they are two-sided markets, prices are zero. So that's a problem, because antitrust authorities, they have been refraining from intervening. What's the point is that you indeed pay with your data, or you pay with your personal information. But so these are interesting concepts because they are universal concepts, and you can look at LLMs through these lenses. Okay. How much time do I have? 10 minutes. Okay. Okay, I asked so that you could breathe for a second. And also because I wanted to know. Still awake? Okay, good. Another interesting, at least to my opinion, interest is something very personal, so what is interesting to me might not be interesting to you, is the economics of access. So we started to see that there are different ways to access to large language models. Okay? The more indeed from just the engine they become products. Okay? And there is a continuum. I don't know if you ever saw this paper from Irene Soleiman, which is called The Gradient of AI Release. That it's funny because the paper is published at the mid of 2023 and all the models listed there are already old, so that Stanford HI, they just remade it a few days ago. And you have, so what we see economically is that you have a plurality of way to access the product. Okay? From fully closed models that you need to purchase or you need only the company internally can use, to the API access, to the LLM as a service where you have only an online interface to deal with the product, to the download of weights, plus code, okay? So we see not only this, what I was telling you before about the dominant design, is that we see that the industry is becoming more complex, okay? It's becoming more complex with more actors, more access to the products, more way to access LLMs. And this goes back to another topic that I forgot to mention in the slides on platform, which is not only the platform is an interesting architecture because it has core and complements, but because the key of value creation in a platform are the interfaces, how the core and the complements interact. So you can make a very nice microphone, but then if it has a plug that doesn't fit, I mean, you can't use it. And you can make a very good LLM, but if you have a very crappy web interface, nobody will use it, okay? So that is very important. And you have this plurality now of access that we should map, because one of the questions is that, are they going to all survive? Are we going to see a dominant way to access LLMs? Once again, this is software, so on the one hand you have increasing return to scale, but on the other hand you also have little cost of trying new, so experimentation costs are lower too. So maybe this plurality will remain, but it's not written anywhere. What is, though interesting, is the fact that this complexification of the industry around LLMs is creating room for new actors to enter. And the actors are not necessarily LLM producing, but they are intermediaries. So what is Hugging Face? Hugging Face is a model hub. So actually it's literally a two-sided market. So it's a platform in which people put where that actually you have direct network effects. The more people upload models, the more people upload documentation, the more utility of other people to go on Hugging Face and download them, experiment, try new stuff, develop, fine-tune, etc. So we see the emergence of model hubs. That's a new type of actor in the AI stack that is gaining quite a relevance, okay? Because that, I mean, Hugging Face is not making money yet, but on the one hand, it makes France proud because some of the founders are from France, and on the other hand, it's showing also other type of market dynamics because it makes partnership with all the tech giants. So they signed yesterday a contract with Google, but they already had an investment of 40 million from Amazon, and then you see that this sort of structural bottlenecks start to form in the industry with the model producers, the model hub and distributors, the final application producers. Sometimes they are the same, sometimes they are not the same. Okay, so information goods as a nature of the product that LLM partially is, platform as a structure that LLM might evolve into or not, access as the incentive to produce value in different ways through LLM products. So you have all these economic concepts that actually, once again, they are not new. They are from pre-internet era and during internet era, but still can give us a little bit of insight of where the thing goes. the other thing that an economist would look at, that actually many economists don't, but because we get, let's say, we fall in love with the technology, is, yeah, nice, a lot cool LLMs. What about their profitability? Like, because there is a very important distinction already between invention and innovation. Invention is a new combination of idea. Innovation is a commercialized idea. So there is a minefield of forgotten invention in the world, in history. Sometimes they just need time to be rediscovered. Sometimes they need complementary technologies to become useful. But we need to wonder now, because there is a lot of, public interest and also money poured on it, whether the LLM-driven businesses are profitable or not. Okay, and because Uber is not profitable and it's still around after Twitter or X is certainly not profitable, and now even less, but it's around for many years. Many other digital apps or markets, they are not profitable, and they survive because of the perspective of growth they provide to investors. Like what usually venture capital want is growth prospect rather than immediate profit. So revenue growth rather than profit growth, because one day if you continue to grow, you will make profits. That's the general story. But in AI, we live in a world that has been characterized already several times by AI winters. Okay? So the idea here is that, okay, we pour a lot of money into that, then people suddenly stop being interested in that. You will see a collapse of all this ecosystem. Okay? So to be a junior professor in economics of AI and say that maybe the industry will collapse, it was not really going along the, let's say, the pitch for the job that I wanted to make, but one needs to be honest. Okay, so what about profitability? So LLMs, we discussed already, they have a lot of use cases. They are already improving the productivity of programmers. They are used already in education. You have chatbots, you have virtual assistant. It's not that you did not have expert systems in the 90s, okay? So these were not LLM driven, these were not inductive or neural network driven, but still you have sort of knowledge structures, ontologies that suggested solutions to companies. And content creation is increasingly used. But there are a lot of buts. First but is that many of these uses are ethically questionable. So I don't know, I was really watching yesterday a video on YouTube where people are watching us on fake Instagram influencers, okay, in my quest to become a real Instagram influencer. And I'm joking, and partially. The point is that, LLMs and image generation models are used to create fake influencers that anyway make real money, okay? So it's the same with fake news. So you can now generate at scale false information. So much for the gain in economic growth and progress and advances in the society. Though, when a generative AI or LLMs as part of, they are used in the workplace, they've seen improving at least the productivity of the least productive worker. So it's not that it's a tool that doesn't matter, but should be treated as a tool, or as a product that has a tool function. Also, not all applications, they really suit for probabilistic systems. Once again, yes, you can draft a contract with an LLM. But do you trust the contract? Or do you, if you ask several times, it produces a different output? Is it something that you really want? So you have a lot of companies that come to us now and ask, like, how can we implement LLMs in our businesses? Like, but do you need to? Must you? So this is something that, we should be clear about. Second point is that there is a nice, it's not an article, it's a reflection by this Hoel in a blog post. So like if you look at the economic growth promises of AI, and the discourse around it. They will say like, generative AI will disrupt creative industries. Okay, but then creative industries, I mean, they have a huge value, but in proportion to the economy, they have a small value. Okay, so even if they disrupt part of it, because they will not disrupt all of it, you saw there were strikes of creators or in Hollywood, etc. Then the potential gain of this technology economically is not so huge. And then where AI does very well is where we have a lot of information, a lot of data to train the models. And where we have a lot of data to train the models, the marginal gains of automating these tasks might not be that big. Okay? So this is something to discuss. The impact is yet to be measured. But word of caution, the narrative between the whole economic system is disrupted by LLMs versus the real impact, even in the billions, is a small fraction of the economic system, should be put back to terms. And then we have all the issues that LLMs as a software, okay, reproducible, variety expansion, maybe domination of some actor over others, but you have the compute cost. So is it, so economists think about in terms of opportunity cost. So it's, there are always trade-offs. Is it worth the candle to use a lot of electricity to run GPU racks in some place in Delaware or not? Environmental toll that was mentioned before. So, of course, the socio-technical dynamics co-evolve. We are talking about environmental toll when we are experimenting with pruned models, more efficient GPUs and TPUs. So this technology improves, but you cannot build your, as a researcher, not as a business people, they can do what they want, but you need to be wary that you cannot believe in the infinite progress of the technology. You need to consider whether these uses, they improve, let's say Pareto improve or not, the society. And yeah, the data is partial. There is this, you can go at the pile, I don't know if you check the pile data set, which is 800 giga of data set to train LLMs just on your, on your computer, your server. And inside they have book tree. Book tree is mostly legally downloaded books. Well, Wikipedia, sure. There are other type of data sets that are, for the moment, used. But I mean, if it's not that the New York Times will win the lawsuit against OpenAI, they will stop developing LLMs, but the cost of developing the model increases. And economically, if I want to sell a product, the cost, hence the price, still does matter. So it's like here there is my colleague Flora Bellone who studied international trade. You know, if you want to externalize production to another country or produce at home, you can have a better technology at home that lowers the price of production, or you can have it done by humans somewhere else where the salaries are cheaper. If the salary go down, you might abandon the technology and put it back on humans. Okay, so the same is for LLM. We now automate a lot of things with language models. If they start to become more expensive, then we might change the trajectory or stop using them. Okay, so the cost and benefits need to be weighted, and if cost and benefits need to be weighted, these lead to industry dynamics. Not all companies. He didn't like the presentation, but it's okay. It's okay. Yeah. So, then not all companies survive. Okay. So what happens is most of industries is that you have new industry, a lot of entry of firms, turbulence, there are high margins. The more the margins are high, the more firms are entering. Then they try to reach indeed this dominant design, and then they start to work on cost reduction. Cost reduction, prices go down. Those firms that cannot sell at a certain price because their costs are higher, they go out of the market. The industry become more, let's say, oligopolistic. Okay. That's something that could happen. Actually, this is something that is happening already, because if you look at the price per million of tokens that now you have to use the main models, you have, this is from a website which is called Artificial Analysis.ai, that is kind of collecting a little bit of this data. So what is happening is that you have the prices, the input prices, so to input in the model 1 million of tokens or more, I mean, and then the output prices, so to have results from the elaboration of the LLM. And GPT-4 still is the most expensive, but once again, because of partial information goods and the head start, still people use GPT-4. And then you have Mixtral that is super cheap, okay? So 3 cents per million, 3 cents of dollar per million token, not 30 cents, sorry. But then you need to wonder, is their cost profile less than 30 cents per million token, or are they just producing, are they just pricing on losses in order to, what is called in economics Bertrand competition, are they just lowering the price in order to try to kick out the competitors that cannot survive? So you have this, so the arrival of Mixtral, that's the model, is a big shock to the industry because it led to this race to the bottom. Race to the bottom not in quality, actually quality increases of performance, but of prices. And this might lead to consolidation. Some companies might be acquired by others. Failure, some companies might exit the market. And indeed, ossification, so there might remain only few. All these dynamics in a context in which we increasingly talk about sovereignty, so there are international competition issue. So you know you might have high cost, but the government might subsidize you because we want the French model or the European model, and so on and so forth. So this is also something that can affect the dynamics. This is why it's hard to predict. You know, once American President Truman said, can you give me an economist with two hands, with a one-handed economist, because economists, they're always like, on the one hand, on the other hand. But it's true that there are several forces at work. Even geopolitical forces, technological development forces, economic incentive forces at work. So this is just to say that there are all these dynamics at work. Do I still have 2 minutes? Okay. And these maybe you that are experts in the field, you will find a bit, how to say, raw. But I was trying to put a little bit these things together and say like, okay, we might have different scenarios for LLM evolution. On the one hand, you can have that after the hype passes or the hype calms down a little bit, you might have that LLM and the associated products, they become a sort of standalone products. Okay, so you have seen Bloomberg GPT, for example. So Bloomberg created a version of GPT to query issues of finance. Okay, that's an executable, I would say. So it's an app that you will use for that stuff. Then you have what I would say is the integration scenario, which is what was presented before by Gianluigi. So the LLM becomes a module in an even bigger platform. So the LLM as a platform, let's say, or as a architecture of a software that becomes a component. And this you see in SIP, but you see, I don't know, if you go on Amazon Bedrock, I don't know if you have ever visited. So Amazon Bedrock, you want to do some image recognition or some text generation or some other task, and then you choose from a suite of models, from Anthropic, from OpenAI, etc. And there, if LLMs become one tool among many, then the economic question is that who makes money, if you want, or where is the value accrued, okay? While in the first case is the LLM company that will make revenues, here is the aggregators who will mostly make money. So the value in the value chain will be distributed differently. This happens already not only in LLMs. So there are, I don't know if you know the concept of roll-ups. Roll-ups are some companies active on Amazon that make short lists of products because there are too many products to check. Okay, so you have this, but it happens also in books. I mean, the New York Times list of books books to read is a way to reduce the computational complexity of reading all the books that are around. So you have entry of intermediaries that compress, that reduce the dimension of complexity of a very large market. The same you have it with potentially with LLMs. And this is, I mean, text generation model, image generation model in Amazon Bedrock, but if you look at Bionemo of NVIDIA, that's as a suite of software for doing, using biology, for gene editing, etc. And they will have, I don't know, AlphaFold plus an LLM plus something else, okay? Plus software to deal with the sensor of their machineries, to analyze signals. So this you have that the LLM is not a self-standing executable anymore as a product, but becomes a block integrated into larger products. And this you see, this maybe is the trajectory that is happening for business-to-business AI. You saw it before. I mean, in the end, SAP will integrate existing LLMs into bigger software solution. If you go back to what I told you about versioning and bundling, is exactly what they're doing. And then they will also offer another thing that I told you is important, the interface, to interact with that. So they will extract value of the package and the interface. And another type of integration which is emerging is, you know it better than me, is VLAs. So VLAs is vision language action models. So the LLMs that command robots, if you want. I don't know if you saw Google RT2, for example. And this is another direction in which LLMs become integrated in more complex cyber-physical systems, if you want. Okay? So this is the trajectory in which LLM become really doing something, but less hyped because they find their place in more complex technologies. And then you have also the platformization of LLM, if you want. This is the case for if GPT Store take over, like if gains momentum. So you have LLMs as the core of a different way to interact with information processing, okay, or the internet. I don't know if you saw at the CIS, so this is a bit hypey, but I don't know if you saw the rabbit. So you saw the rabbit, okay. So this little device. Okay, so this could, at the moment, I would say could still be an empty orange box with nothing inside. Maybe. We don't know. So if you look at the video that explains nothing. Even though they have an archive paper to refer to in their website. However, this, to me, seems very much a little bit the idea of going in the direction of transforming the hardware-software tandem-driven experience of internet as one shaped by LLMs. Okay, so we might envision a near future in which indeed you interact with text and voice through devices. The more compute of device become powerful and models become portable. Okay, so these are all ways in which I think that we face LLMs are potentially transformative solutions. Well, and I close. Are potentially transformative solutions. They are also very much hyped. They can follow different paths of evolutions. They clearly have use cases, but they also have clearly problems. And some of these use cases are very transformational, and some are overrated. What matters is indeed if the feature of information good, platform style issues that characterize LLM will make them gain in momentum or maintain in momentum or not. And depending on many techno-economic and social forces, there might be different scenarios in which these ones will evolve. So to return to the hypothesis at the beginning, so are we going to see the interactive AI phase? Yeah, maybe if LLMs become the cornerstone of a more platformed way to interact with the internet and information systems, but who does that must be profitable. Otherwise, this trajectory dies out. Or not really if the main evolution of LLMs is to become only a piece of larger packages of software and versions and bundles that companies offer to commercial clients. Are the LLMs the dominant design for the industry? It is true that having some feature of information good, they push for tipping. So we saw entry of new models. We saw race to the bottom in pricing, but we also see that this cannot last forever, so it might lead to the stabilization of the industry. So what we see now, my take is that very much undercutting behavior, so attempt to kick the competitors out of the system to gain market shares. And these usually lead to what are called industry shakeouts, so phases in which a lot of firms fail, go out. So the automotive industry at the beginning of the 20th century in the US, there were 400 companies producing cars. After the 40s, there were 15 companies. Okay, so you have this shakeout period, driven by different dynamics, but that's also what happens. Might be less strong because we're talking about software, but it's a software very much related to compute, so you have big investments behind. And I mean, yes, you can get the support from the tech giants. If you are alone, you cannot do it. So these are trends that we might see. These trajectories are different for business and for final application users. And what I wanted to suggest, I think, is that there is a nice scope for interdisciplinary studying of LLMs and AI systems, because often who develops software is very much focused on the techniques without having the bird's eye view, and the social scientists are over-focused on the bird's eye view, not understanding anything of the techniques. And maybe it's not a gray area, but the intersection of the Venn diagram, it's a good space for productive research. So thank you, and if you have questions, happy to try to address them. Questions? Yes.
Yes, I was wondering about your second argument about the profitability. I didn't really get it because you were saying for creative industries, okay, there's not a big problem, and actually LLMs are quite are just bringing marginal gains in the case of areas where you have a lot of information already. My understanding is that, on the contrary, if you have a lot of information, you have higher gains because you're able to automate what you do out of those information. So my understanding is you have higher profitability in that case. Plus, for creative industries, you also have the IP gains with respect to trained personnel, if I can say so, at the cost of IP, maybe.
So thank you very much, Yves. And so the point there was more like, so we have a lot of pictures, let's say, to train image generation models. So that's a lot of data. So that could substitute all the people that you can hire for very cheap prices on Amazon Mechanical Turk to draw a picture. Yes, you can. So there is a scope for adoption of the technology, and there is gain to be made, but the aggregate societal value of doing that, maybe, is not that large. Okay, so some companies might be profitable with that, but in all or music generation, yes, okay, the singers and artists, they make music, but then they make music out of concerts, and they got nothing out of streaming. So even if we have a lot of samples and we make AI music, then we stream, then at the aggregate level, let's say, of GDP gain, that's not so large. And I said that only because, so to qualify, because I mean, then you are right in general, that it's not that there is no scope of making, to be profitable, but that the turbulent markets like this one at the very beginning, they are very much building on inflated expectations on returns, and there might not be so large. So that was mainly the thing. And the other point when I mentioned cost changes is that, okay, you hire a graphical designer through Amazon Mechanical Turk in UK, costs a lot, maybe better a generative AI model, but then you hire the person for somewhere else, and you can chat with this person, still the performance is higher than an LLMs, and then you prefer to pay a few cents. So that open up a full other discussion whether the work that goes inside AI and the work that compete with AI, whether it is well rewarded, whether it represent north-south relationship of exploitation, etc. But that goes a little bit beyond what I wanted to say. But yeah, so I just would be realistic on the potential of LLMs to create society-changing value, let's say, economic value, even though some, for sure, there is. So the very programming, maybe, for example, we discussed that a bit during lunch, but in some sectors, there are productivity gains to be made. When we talk, though, at the societal level, we always have to compensate. You know, for example, you can have automation processes, LLM-driven inside the companies, that draft your email, summarize the email, send it to a colleague, and then de-summarize the email and send it to another colleague, etc. But then you will have to hire 10 project managers to do tick boxing tasks. So this is what, I don't know if you've ever read this book of David Graeber called, I don't know if I can say it on YouTube, but it's the title of the book, which is Bullshit Jobs. So there is a lot of job creations that do not, with humans, that do not add so much value, while we get productivity improvement through AI, not only LLMs. So the aggregate effect for the society, we still need to estimate it. So I don't know if that answered, but somehow I hope it addressed it a bit. Go ahead, there was also a question there, but you can go first.
Presentation of LLM. Yes, thank you. Your view as an economist on by region of the world, it seems to me that the US companies are growing as crazy, like GAFAM has been mentioned, and BATX and so on. What is left in your view for Europe and the rest of the world in this game?
Very nice question. Well, also the previous one was a very nice question. And declaration of preferences. So I would be very happy to see a European action on the AI front, because on the one hand, this would fit under the re-emerging umbrella of industrial policy, but where the industry is not only manufacturing, but is also digital industry. We, however, have plenty of examples of public resource waste to try to catch up with the frontier and then not catching up with the frontier. And exactly because I mentioned before two-sided platforms, etc., because this type of businesses, they introduce a lot of tricky issues to consider. For example, if what we care as a society is pushing the frontier of AI in general, then it is the same problem as consider Google And if what we care is consumer welfare, so lower prices, then better to have one Google than two Googles, because if you have two Googles, the users will split in two, which will reduce the number of advertisers, which will ask these companies to raise the prices, which will reduce their welfare. Now, you can measure welfare in another way, or you could say it's not only the matter of the prices that you pay, it's the control of the market and the monopolization, which is bad in general. But these are discussions that we need to start to do in AI, which are not so developed. So, to return to your point, despite the risk of, for example, potential waste of resources, I think we need to be clear on which are the objectives that we want to achieve. So, for example, if we want to achieve inclusive AI, explainable AI, AI that is used not necessarily for geopolitical strategic issue or to foster the dominance of some countries on the world stage, then becomes an issue of industrial policy. And therefore, I would support policies in that, let's say, that creates more competition or plurality in the AI field. Why I said expression of preferences, because I think a very strong thing we need to avoid, as we always do, is methodological nationalism, meaning that the French model, the Italian model, the German model, they are very harmful. We are already blocking the AI Act because first Germany was in favor of the AI Act, and now it's like, but Aleph Alpha, maybe they should grow because for the glory of Germany, and no, Mixtral, actually we should subsidize, so only the model more than X billion parameters, they should be controlled. So the factionalization of Europe policies on a national perspective, I think, always harm welfare more than it gains. If we think more in a European or global scale, how we make AI more distributed, then is a better reasoning, in my opinion, though. So that's so initiatives should be at least European initiative or global initiatives to govern AI, discuss the impact of AI. And what I want to add, if I can, is, may I, Chair? Yeah, is that why I presented this kind of topics is that is because a lot of the impact of LLM products in the market are typical products that create consequences for users, consumers, and producers, not existential risk. Okay. And on the existential risk, that's a very dangerous direction to go in, given the communities that support this kind of reasoning. So a lot of global governance of AI has been focused on that. Maybe we should focus on global competition policy of AI rather than global, I don't know, security from risks that do not exist. But yeah, so I think that's a very important theme we should focus on. Here I wanted to stress that there is a market aspect that we should consider in depth.
Yeah. Thank you very much for the amazing presentation. I think that's a view, an angle on the topic which is very useful and too many times missed or forgotten. Something that you mentioned a little bit, but that I'm still not understanding is most of what you said is based on the current state in computation, and there's kind of a monopolistic situation with NVIDIA providing the computation for everyone. Still, there is a player that could explain and that could actually take all or at least share with NVIDIA, which is Google, because they have their own computational resource. And I still don't understand why they don't go against NVIDIA. They have their own resources on the cloud, okay?
This is I mean, also the previous one was a fantastic question, and the previous one. But this just tickles my interest because it's something that I started to work on, which is vertical integration in the industry of AI. So stay tuned. Some paper will appear at a certain point with academic speed, which means when it's not worth anymore reading it. Anyway, so I do not have an answer of why not, but it is indeed interesting. So it's double interesting from my perspective because these patterns of industry consolidation, they are self-similar across many industries, indeed, cars, lasers, semiconductor, pharma, but when we go on the software industry, plus software that is connected to hardware, they become more non-linear, let's say, okay? So there is always some radical innovation that can break the pattern or the stylized fact, as we call it. So, which is the same of, automotive industry is very standard, then Tesla arrives, and then you have a new way of producing motion, and then previous remains, now we are in the transition, but the industry has been rejuvenated somehow. Same for industry. So for example, I can talk a little bit more, I know about semiconductors. What we see is that, so the many markets, at the outset, they are vertically integrated. So meaning one company does everything. Then the more the market expands, the more you have room for entry at different layers, so that semiconductor now is very split, with related geopolitical problems, because then so most of the chips are done in Taiwan, and maybe that could be an issue at a certain point soon. And that drives industrial policies and bring production in-house or at home, etc. But then the semiconductor industry, over time, we have seen the coexistence of vertically integrated producers, like Intel does everything, and Samsung sometimes does everything, and very specialized industry. So ARM, it does only the design, and others, they do the packaging, and so on and so forth. And the incentive here, I think they are a combination of, so also firms are bounded rational, so they don't know how the industry is going. They have the resources to explore many trajectories, but I think they are, sometimes they are not sure, sometimes they do not have the knowledge to produce as good as other companies. So maybe a TPU is very good, but it's not as good as a rack of 800, or in terms of market coverage or complementary services and so on and so forth. And I think but that's my personal take though, what they experience is a mixture of economic reasoning, in which they try to have the most efficient structure. Like sometimes it's better to have contracting, so buy rather than make. So they might focus on their core business, they might explore better, they might do something else, so they leave space to NVIDIA, let's say. And the other pressure is the pressure for market dominance. So they want to control the market, so they want to increase their market share. And I think in the end, they're made of people, the companies, so they weight this stuff. So they're like, okay, here it makes sense that we contract, here we do not have enough experience. We saw, there are cases like in IBM itself, they were entering the peripherals market to try to integrate, then they realized that actually they were producing at very high cost or crappily, or they did not have the knowledge, or the talent was going away, and then they became a platform once again, so they became a core with the external peripherals. So I don't know, I couldn't assign a weight, to use a neural network term, to what drives most, but I think it's a linear combination of all of these forces. It's clear that there are looming potential radical innovation that can change. So if, I don't know, I like very much neuromorphic computing, so you're like, okay, then one day neuromorphic become very efficient, or not only on sensors or on memories or on specialized, they become more general purpose, then the entrant in this type of sub-industry might then conquer the whole industry. But we're not yet there. So yeah, I mean, it's a space to watch. To me, it's very interesting because it's the same story with the semiconductor. So in the end, so we wrote a paper, did not post it here, but with my co-author Ekaterina, we wrote a paper on how the needs to cater for AI-driven computation is changing chip design, because in the end, the more you need to do AI, the more you have need for parallel of certain type of parallel computing. So you have not only the emergence of GPUs, but GPUs, they also need central processing units. So you need still flexibility of computation. And what does this mean for chips? On the one hand, you have commercial specialized chips, but on the other, you have platform chips. So you have indeed the M1 was our example, because you have the CPU, the TPU all together in a system. And so you have these shocks to an industry, and then you have the rearrangement in structure, in product design. All this to say that these are all things that one can try to give away to, but it's very hard to see the direction where it goes. But something that would be nice to continue to look at. Yeah. Thank you. Thank you. You have the email there if you have other questions.